Okay, so have you seen an equation where the variable is stuck in the exponent and wondered how to solve it? So in this video, we'll explore how to handle these types of equations using logarithms. So logarithms are the key to unlocking exponential expressions and solving for unknowns. So here, these are the 4 steps that you have to follow if you are trying to solve an exponential using logarithmic forms. So first step is to rewrite your equations with the terms containing exponents by itself on one side. That means you have to isolate exponent on one side of the equations. So the next step is to divide both sides by the coefficients of the terms contained in the exponents. Then you have to change the new equation to the logarithmic form, and finally you have to solve this. So I will explain all these steps using some examples. So let's start with the first example. So let me give you this equation. Let's say 1600 is equals to 10 to the power x. So you have to solve this equation for x. So to solve this equation, I'm going to use logarithmic form. So let's try to apply these steps. So the first step is, that means in first step, you are asked to isolate the exponent on one side of the equation. So I have an exponent on one side of the equation. It is already isolated. So I don't have to apply the first step. Let's move to the second step. The second step says, if we have a coefficient in front of this exponent, we have to divide both sides by that coefficient. But in this case, we don't have any coefficient, so it's just the exponent. So we can skip step number 2 as well. So the step number 3 says change the equation to logarithmic form. So now we have to change this into logarithmic form. So here the base is 10 and the exponent is x, and this is my output. First of all, let me write the relationship between exponential function and logarithmic function. So let's say y is equals to e to the power x, not e to the power x. Let's say y is equals to a to the power b. So this means log base a, what output y is equals to exponent b. So this is the relationship between exponential function and logarithmic function. So I'm going to apply that relationship over here. So this is equivalent to log, the base is 10, output is 1600, is equals to x. So if you solve this part, you will get the value of x. So to get this, you can use your calculator, because in calculator there's an inbuilt button that you can get log 1600, because this is common logarithm. The base is 10. So if you calculate this, you will get the value as 3.2041. So here you can use your calculator. Let's do another example. Let's say e to the power x is equals to 2500. So here also this is an equation, so you have to solve this for x. So first step, you have to isolate the exponent on one side of the equation. So here I already have the exponent term isolated on one side, so we can skip step number 1. So we can skip step number 2 as well. It's because there's no coefficient involved with this term. Let's try step number 3, which means you have to convert this into logarithmic form. Again, if you apply logarithmic form, the base is going to be e, and the output is 2500 is equals to exponent x. So this is natural logarithm. So we can rewrite this as ln 2500 will give you x. So now in order to get this value, you can use your calculator again, because in calculator there's an inbuilt button for natural logarithm. So if you use your calculator, you will get x as 7.8240. Okay, so let's try more examples. Let's say 10 to the power x is equals to 4600. Okay, so here also we can see both steps 1 and 2. Let's move to the third step. So let's try to convert this into logarithmic function. So this is going to be log, the base is 10, 4600 is equals to x. So the log 10 means it is log, the common logarithm, 4600 is equals to x. So if you use your calculator to evaluate log 4600, you can have the value as 3.6627. Next example. So let's say we are interested at evaluating e to the power x equals 54.6. Again, the exponent is on one side of the equation. There's no any other term, there's no any coefficient. So let's apply the logarithmic form. So here x is equals to log base e 54.6. So the logarithm with base e, it is natural logarithm 54.6, which is equals to x. So now you can use calculator to evaluate natural logarithm at 54.6. So once you get that, you'll get something like 0.4.000. Next, let's use next example. Let's say we have 8,000 equals 500 multiplied by 10 to the power x. Okay, so here the first step is to isolate exponential term on one side of the equation. So here there's only one term on this side, so it is isolated. So we can skip step number 1. The second step says divide both sides by the coefficient of the term containing the exponent. So here this term we have 500 multiplied by the exponent. So first of all we have to get rid of this 500. In order to get rid of that 500, you have to divide both sides by 500. So in this example we are going to apply step number 2. So if you divide 8,000 by 500, you'll get 16. So 16 is equals to 10 to the power x. So now we can apply step number 4. Apply the logarithmic form. So x is equals to log, the base is 10, output is 16. So again, use your calculator to get log 16. So the value will be approximately equals to 1.2041. Let's try one more example. Let's say 5200 is equals to 13 e to the power 12x. Okay, again we have to isolate the term exponent term on one side. So here we have only two terms, they are on either sides of the equation. It is already isolated, we don't have to do any more calculation. But let's move into the step number 2. So we have to divide both sides by any coefficient. So here we have 13, which means we have to go ahead and divide both sides by 13. So in that case, you will get e to the power 12x on this side. And if you divide 5200 by 13, what do you get? You'll get a 400. Okay, so now let's apply the logarithmic form. So it's log, the base is e, the output is 400 is equals to the exponent 12x. So now log e means it's ln 400 is equals to 12x. So now we can use calculator to get ln of 400, which will be equals to 12x. It is equals 5.9914. So to get the value of x, you have to divide both sides by 12 because you have to get rid of that 12. In that case, you'll get x equals 0.4992. So you can use your calculator to get these answers. So this is how you use your logarithmic forms to solve exponential equations.